Hi everyone, welcome to our video on the substitution rule for antiderivatives or indefinite integrals. So the substitution is for really doing antiderivatives that are complicated and making them into something that's real nice, like this. So this table. So instead of x, we have u's, but notice these rules. So this is still just the power rule, the first one. The second one is our e to the u rule, just like if it was e to the x. And then our last one is the natural log rule. Okay, so let's see how this works. So on these examples, we have perfect substitutions. So we're going to use a substitution to evaluate the following indefinite integrals. All right, so in example 1, they're telling us let's u equal 2x squared minus 9. Okay, so what we're going to do, I'm going to put that over here. Let's put it in blue. So they're telling us use this u equals 2x squared minus 9. And then as soon as we find u, we're going to find its derivative. And the way that we mark it is this. So this is the derivative of u. So let's put that up here. So this is the derivative of u. So you could also say it's like u prime if you prefer, but often we use du for these scenarios. Okay, so du in this problem is, well, it's just the power rule, 4x, and then what we need to do though is attach a dx. Okay, so with this scenario we attach dx. Okay, so with the substitution rule, attach dx with substitution rule. Okay, and we'll show why in our next step. Okay, so here's our integral. What I'm going to do in this integral, I'm just going to move this 4x over there. So I'm going to do that real quick first. So this is still the same antiderivative or same indefinite integral where I have 2x squared minus 9 raised to the 10th power, but I'm putting the 4x dx next to each other. Okay, so all I wanted to do is move that. And so the reason that I move that is because now I have my substitutions that I can use. So notice this is a complicated integral. None of us would want to take the 10th power of this. That means that's a lot of foiling, so that would take a very long time. And there's no other way to do this type of integral unless we make it into one of the ones that looks like from our table here. Or you can even think of the ones that were from, let me just scroll, like these tables. Okay, so notice it's all very basic that we want to make these functions into so that we could do the antiderivative. If they're crazy, then that's a problem. We need to make them so they are very nice. Okay, and what this substitution does is it lets us do our integration. So in the blue, let's go ahead and bold this. This is u. So this whole thing in the blue, let's start to rewrite. So our integral's still there. And then that in the blue is u. It's still raised to the 10th. That's okay. And then everything here that I'm going to put in the red is du. Okay, so notice right there is our du. So that means that we could just rewrite that as du. Okay, so what we're doing is a substitution to change the variable into u's. And then now it's just the power rule. So now I could do the power rule to continue doing this problem. So let's show that. I'm going to do it in, let's show our final, or not our final, but the step for the antiderivative in purple. Okay, so our power rule tells you, well, add 1 to the power, so that'd be 11, and then multiply the front by the reciprocal of that power, which would be 1/11. And then always still plus our constant c. Now, we're almost there, we're about there, but our next step, which is near the end, is to rewrite our u expression into the original variable that we started with. So now I'm going to go and sub this back in for that. Okay, and so then this becomes, let's write it as 1/11. And let me use my blue still, so it would be 2x squared minus 9 raised to the 11th, and then plus our constant c. Okay, so that's how we do a substitution, and they gave it to us. That's okay. We'll eventually figure out the ways to figure it out ourselves, but this is it. And then just like always, you can check. So this requires the chain rule. The 11 would multiply the 1/11, so you'd have 11 over 11, 2x squared minus 9, minus 1 from the power would be 10, and then multiply by the derivative of this inside blue parentheses, which would be multiplied by 4x. And then the derivative of a constant is 0. Okay, so 11 over 11 just cancels. And notice it is the same as what we started with in our original integral. Okay, so that's that, except again, the order was a little rearranged. All right, so that's how we could do these problems. All right, so let's do two other perfect substitutions. So in the second one, they told us what it should be. Let's put that to the side again. I'm going to do my blue. So often our u, I keep to the side, and then we'll focus on our substitutions in the original integral in a second. Okay, but they're telling us let u equal 20t. So we have 20t. And as soon as we find our u, we want to find the derivative of u, which is 20. And then again, in these scenarios, we attach dt because we want to see it when we plug it into our integral. Okay, and then similar to the first one, I'm just going to move this 20 to be with the dt. So let's say that this is e to the 20t, and you can even put that in parentheses, and then I'm just putting the 20 with the dt. Okay, so I have it looking like this now. And then now I have my u that I can sub in. Okay, so the u is, I'm just going to box it, so that there is the u. And then the du is this whole thing in this parentheses. So that way I can change this more complicated expression into the a basic one. So that's our main goal every time. So this is e to the u and then du. Okay, so I'm just showing the colors again. So all we want to do is make it into one of these three easy scenarios. So that's all the substitution rule is doing. So it might start off weird looking, but eventually we should have something nice. Okay, and then I'll use purple again to show I'm doing the antiderivative. The antiderivative of this is just e to the u plus our constant c. And then now one last time, I want to go back to my original letter. My equation here will let me do that, where I can sub in. So let's rewrite it. Our final answer is e to the 20t, and then plus our constant c. Okay, and then like all antiderivative problems, you could do a quick check. Okay, so our check, the derivative of e to the 20t is itself times the derivative of the power. And then notice again, that matches what we have. It's just in a different order. So check, it's good to go. Okay, and then one more where we have this perfect substitution. So like the other ones, I like to just go ahead and write our u to the side. So we have u is the natural log of y. And the derivative of that, so we'll write it as du equals 1 over y. And again, just make sure to attach dy to the end. So all it is just attach d whatever the letter is. So on this, on the second one was t, that's why we did dt. On this one it's y, so we attach dy. Okay, so we just attach it to the end to show we did the derivative with respect to whatever letter. So dy is just attached. Okay, and so on this, there's actually a typo in this problem. So the dy was left off, so that's my fault. It will be fixed before you see it, but on this video, it's not. It should really look like that. So the dy got forgotten. So that's a mistake. So that's not how it should have been written here in the typed. This is what it really should be. Okay, and then what we have, again, all I want to do is just make it match with what I have. Notice with the du too. Let's go back one more. So dy is treated like its own variable. I can multiply the 1 with it. So this is dy over y if I prefer. Okay, which means in my integral here, I could rewrite this. So this is the integral of 4 natural log of y and then dy over y. So all I'm doing is just putting the y over the dy instead of the natural log of y. And if it helps, you can even put parentheses on it. Okay, and then now I should have everything that's ready in my u and my du and the blue and the red. And so notice I've got this here. That whole thing is u. And then this whole thing right here is my du. And so we can rewrite this. This becomes 4, so the integral of 4. Natural log of y, we're saying, is just u. And then the dy over y is du. Okay, and then now I can do my rules for the antiderivative. So 4 let's do it in purple again to show I'm now doing the antiderivative. So 4 is just hanging out. The antiderivative of u would be, well, add 1 to the power and make it squared, and then multiply the fronts by 1/2. And then, like always, add c. Okay, so now let's do 2 steps in one here. So we can do the 4 times the 1/2. That would be just 2. So let's just say this is 2. And then let's also now change our u back to the original variable expression that we had at the beginning. Okay, so it should be the natural log of y getting squared like that. And then plus our constant c at the end. Okay, and then again, we could check real quick, do a check. The 2's just hanging out. The derivative would require the chain rule. The 2 would multiply the front, and then we'd have minus 1 from the power would be the natural log of y, but then times by the derivative of the inside there, the natural log of y, and it gives us 1 over y. And then we know 2 times 2 would be 4, and then this does match what we started with in our problem. Okay, so that's how we break it down. Okay, so notice the substitution rule. Before going to it, I'm going to write it in green. From this step to this step in all of them. So from our initial variable to the u expression. Oops, let me rewrite that one. Okay, so in all of these, from this step to this step in all these, so the ones that I'm marking in green, notice it's a product. So it's something times something. So the blue times the red is a product. This whole thing times the red is a product. And then this whole thing times this whole thing is a product. So what we're doing with the substitution rule is we're changing a product into into a basic one of these rules. So all of these weird products became something that was basic. Okay, so that's it for now, though. Okay, so we have this is our substitution rule. All right, so we'll do a bunch in the next video. But for now, that's it. If you do have questions, let me know. Thanks for watching.